Okay, so last thing I want to go over with ionic compounds is drawing Lewis dot structures. So I have here the worksheet you're going to be working on in Google Classroom, and I want to go through the different steps. So when you're doing these, you're going to be drawing Lewis dot structures for your ions. So first of all, potassium bromide, we know, has a formula of KBr from the matter unit. Now, potassium, if you look at your periodic table, has one valence electron. So if we draw the Lewis dot structure, we draw that one valence electron as a dot. Bromine is in group 17, and it has 7 valence electrons. So potassium is your metal, bromine is your nonmetal. And remember, the metal is transferring an electron to your nonmetal. And as you see here, potassium is transferring its one valence electron to bromine. Potassium, the metal, ends up with no valence electrons, has a positive charge. So we draw it like this. And our nonmetal ends up with 8 valence electrons and with a -1 charge. And we draw it in brackets like this. Now, sometimes there will not be a nice 1-to-1 ratio like this. So let's do a different one on this sheet. So I'm going to go down here and do aluminum sulfide. So we know from the the bonding chapter, the matter chapter, that this would be Al2S3. And now we can see why this is the case. So aluminum has 3 valence electrons. Sulfur has 6. And for our purposes, I don't mind where you draw the dots, just don't pair them up until you have one dot on each side when you're doing these. Now, aluminum can only transfer 2 of its electrons to sulfur because sulfur cannot end up with more than 8 valence electrons. So if aluminum is not stable yet, it has another valence electron, so we need another sulfur. Aluminum could transfer its third electron to the other sulfur, but sulfur is now not stable and needs another valence electron. So we need another aluminum. It can transfer its 1 electron there, but still has 2 electrons, so aluminum is not stable. So now we need another sulfur. So now aluminum can transfer its last 2 electrons to sulfur. So if we were to draw this final structure, what I would do is I would draw the 2 aluminums. So I would have sulfur in brackets with 8 electrons. So nonmetal always has 8 with a -2 charge. Aluminum brackets with none. Another sulfur with 8. Another aluminum with none. And last, sulfur with 8. So when you're doing these, you do not have to go through this whole process. What I want to see is I want to see your final structure with the brackets. The number of your metals, number of nonmetals should match up with your formula. So here we have 2. So we should have 2 aluminums, 3 sulfurs, 3 sulfurs. You do not want to have the same charge next to each other, so I can't put the sulfurs next to each other or the aluminums next to each other. Make sure your metal has no dots when you're done. The nonmetal has 8. And if you have something like a Roman numeral, you're assuming that lead starts out with 4 valence electrons, for example, for C. And just remember something like silver and zinc. We went over those charges on your periodic table. So try these, and you do not also have to arrange them all in a line. They could be like in a like above and below. They could be on multiple lines. So try these and see if you have any questions.